Okay, the goal of this video is to give you enough information to allow you to use a particulate detector such as this Dusttrak DRX detector. Okay, so for most conventional gas detectors, they spit out numbers in parts per million, and I think we're all pretty good at understanding what 1 part per million is, what 10 parts per million is, and what this means when you look up, say, your short-term exposure limit or your IDLH or something like that. The trouble is, with a particulate detector, we need to know two different things. We need to know size, and we need to know mass. So let's talk about them individually. When it comes to mass, obviously we know what a kilogram is. If you break a kilogram up into 1,000 parts, you end up with a milligram. This is 1/1000th of a kilogram. If you break a milligram down into 1,000 parts, you end up with something called a microgram. It's this weird shaped U, and that's 1/1,000,000th of a kilogram, or 1/1000th of a milligram. So a lot of the numbers we're going to be getting are in these micrograms, and you need to know how to convert between the two of them. If you end up with 0.051 milligrams, you multiply that by 1,000, or you move the decimal place over by 3 positions to get the value in micrograms. 51 micrograms. Because sometimes you're going to find, say, the threshold limit value, the time-weighted average threshold limit value in micrograms. Sometimes you'll find it in milligrams. Sometimes the detector will read in milligrams. Sometimes it'll read in micrograms. So you need to be able to mentally make the jump between milligrams and micrograms. Okay, that's mass. A related term is density. If we imagine a 1 cubic meter space of air here, and we have 1 milligram of dust floating around in it, then the density is going to be 1 milligram per cubic meter, or 1,000 micrograms per cubic meter. If it's cleaner air, we might only have 10 micrograms per cubic meter. So we might get a reading something like this: 10 micrograms per meter cubed, which would be the same as 0.01 milligrams per meter cubed. Hope that makes sense. This is a density, this is mass. The other thing we need to know is size. Size matters when it comes to particulates, because if you had a giant particulate that was 1 centimeter in diameter or 1 centimeter long, you're unlikely to swallow that. And if you swallow it, it's going to get stuck in your mouth. It's not going to go down your throat. So just as we measure mass in kilograms, milligrams, and micrograms, we measure size in meters, millimeters, which is 1/1000th of a meter, and micrometers, which is 1/1,000,000th of a meter. You've got to understand micrometers, and you've got to understand micrograms if you're going to be doing this kind of stuff. So the smaller something is, generally speaking, the worse it is for you. The smaller something is, the deeper it's going to go into your lungs. It's going to, instead of getting stuck in your eyes or getting stuck in your nose and throat, it'll travel down. If it's really small, it's going to travel into the alveoli at the end of the lungs. And that's where the really dangerous stuff is. So some of your TWAs, some of your IDLHs are going to be in just sheer mass or sheer density. It's going to say you're allowed 0.01 milligrams per meter cubed for 8 hours a day for 5 days a week. Okay, cool. And other chemicals and other compounds, such as wildfire smoke and air pollution, are going to be in particle size ranges. So you need to understand both mass and mass per cubic meter, and you need to understand particle size. And when it comes to particle size, we're talking pretty small particles. This detector that we have, other detectors will be different, measures 15 micrometers or smaller. For our purposes, that is your total particulate matter, or TPM. So less than 15 micrometers. Another important value is 10 micrometers. Less than 10 micrometers. So typically 10 micrometers and smaller is called the thoracic portion, because it'll come in, it'll bug your eyes, it'll bug your throat, it'll bug things in your thorax, but it won't really get deep into the lungs. The next size range that's becoming talked about more is a respirable portion. So that is the stuff that gets into your lungs. The stuff that really starts getting worrying is the smaller than 2.5 microns. So particles that are in the air that are smaller than 2.5 microns can get all the way into the end of the lungs. It can make it all the way down into the alveoli. And thus, this is the portion that they're looking at when they're trying to declare air quality emergencies. They'll give you a value, something like, right now we've got 0.01 milligrams per cubic meter at less than 2.5 microns. The final size we're worried about is less than 1 micrometer. So this is what our detector shows us. It shows us a density of milligrams per cubic meter or micrograms per cubic meter at each of these sizes. So obviously this is gonna be the biggest number, that's gonna be somewhat smaller, this is gonna be somewhat smaller, that's gonna be somewhat smaller, that's gonna be somewhat smaller. And for certain things like, say, air quality advisories, where there's a wildfire and there's smoke all over the place, it'll typically be the 2.5 micron level. So you might get a report saying the air quality is really bad. We've got 100 micrograms per meter cube at less than 2.5 microns. And so you'll see this sometimes written as a PM 2.5. This would be a PM 10. This is a PM 4 or respirable. This is a PM 1. So now you understand when somebody says, we've got this many U grams per meter cubed at PM 2.5. Now that you understand that stuff, you can use the quick reference guide and the manual to figure out how to use this machine. Now you'll understand what those numbers that you're getting actually mean.